Hey everybody, this is Larry. This is day 40. What? Day 24. No, not even. I'm wrong again. Day 25 of the June Leetcode Day Challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's film. Oh, and we have a heart. I don't know why the submission is like right there. How do I. What is going on with this thing? Alright, I don't know. But anyway, we have a hard poem. So let's take a look. Yeah, I ran a couple of miles today. I was trying to do a little bit of speed, but not too much because my body is still recovering from the 50K, which I also forgot that I have to do the video on. So, yeah, well, update at some point. I mean, But I hope everyone's doing okay. I mean, I went and it was like 100 degrees. What is 100 degrees in Celsius? It was 37 degrees when I went today. So, it was very hot, you can say. And I just ran like 4 or 5 miles, so nothing too much. But I am, this is me after taking a shower and going for a walk, and all these things. But I was a mess. So yeah. Anyway, let's take a look at today's problem. We have 2040 Cave's smartest product of two, sort of way. Oh, actually, I want to say two things. One is that, again, if you wonder why I'm talking about my training, is because I think a lot of things in life are parallel. There are parallels to a lot of things in life. I kind of talk about my training as a way to, think about, well, what you're doing now on Leetcode. That's training too, right? I mean, obviously it's not one-to-one. It's not quite the same with the physical aspect and stuff, but it can certainly feel that way. Everything can feel hard and stuff, right? And on that note, I want to talk a little bit about motivation. I think one of the more popular questions, and maybe I need to do a separate video on this, is about how do I keep myself motivated? And honestly, the answer is I don't. For me, these problems are like 5 minutes, right? Or maybe a little bit longer. But they're relatively okay, straightforward, and it's not that hard for me, right? Which is to say, like, it's like if I go to the gym and I'm playing with a 5-pound dumbbell, or something like that, or benching, I don't know, 20 pounds or something. Like, it's a light weight, right? Am I working out? Yes, but am I pushing myself? Definitely not. Not even stressing myself. So you have to kind of keep that into perspective, right? And I don't mean this in a mean way, but but you're not me, right? We have different capacity for different type of work. So I'm able to keep the streak going because it is, a lot of problems are like that for me, in that I could get it done in 5 minutes, 10 minutes, and no problem, no effort. A lot of things are easy, right? And once in a while, and maybe this one, because it's a hard one, it'll take like an hour or two, but no, for the most part, right? So streaks don't matter that much, if you ask me, and stuff like that, right? And then the other thing is about motivation, right? Is that the way to do these consistently is not to be motivated, to be frank. It's the same thing that goes into my marathon training as well, right? Because being motivated means, well, what does that mean? That means that when you're unmotivated, you're not doing it. But that's giving yourself a choice. When I was younger, I mean, maybe this doesn't apply to me as much for marathon training per se. When I was younger, for me, this was not a choice. It was either that or, like, I'm doing this to be better, to get a job, to put bread on the table, to eat, That's not a choice, Like, I don't know, where's the choice there, right? Like, in the sense that, like, what do you want me to do? Starve? I don't know. So that's the thing for me. I don't know. Maybe you're in a better situation and that maybe, your parents or something, I don't know, right? But I'm just saying, like, for me, that was never a choice. And therefore, it doesn't matter if I'm motivated or not. I'm doing it anyway. That's how I used to think about it. And, that's how you have to figure out a way to, at least in marathon training and in running in general, there is this idea of, figure out your why. Why are you doing this? If you could figure out this, and if it's really meaningful to you and it's true to you, then it's not motivation that keeps you going. Motivation can only get you so far. Motivation can get you, maybe a week, maybe a month, maybe even a year. You have a lot of grind, but you will burn out. You will get burned out. You have to get to a place where, it's not about motivation. It's just about process. It's about discipline. It's about habit. It's about consistency, right? Not about motivation. Just getting it done. It's like it's almost like, you know, when it becomes habit, you just do it, right? Like, do I need to be motivated to go get food? I don't even know what does that even mean, right? So exactly. Anyway, all right. That's a little bit of a rant. I don't want to go over too much more because this is a hard problem, so maybe I need the time to go over the hard problem today. But I did want to kind of, you know, talk about that. And if you have further questions, definitely ask in the comments and we could talk about it in future videos, etc. But hopefully, you know, because I do get those questions asked a lot, so I want to give you a little bit of how I think about it anyway. You know, your mileage may vary. You could figure out however you need to do to think about it, of course, but that's how I do it. Anyway, let's take a look at today's problem. We have 2040 Cave's smallest product of 2 sorted arrays. Oh, I just want to add one more thing. Sorry about the detour. When I said that like things are easy for me, you know, I want to be clear about this one point, in case in case someone takes it the wrong way. I don't mean it in an arrogant way or in that like, oh, I'm so super smart kind of way. No, it's because if you're not where I am or whatever in terms of, you know, I've been doing this for many years, but what I mean by that is that I put in a lot of work over a lot of years. Every mistake that you are making today, I've probably made 10 times or something like that, like maybe even more, because, you know, I keep making the same mistakes, so maybe that's not a good thing, but eventually I do learn, right? So, you know, it's like when someone asks me like, oh, how are you able to debug this thing so fast? Like I look at someone's code, I help them. I was like, oh, you're doing this. I'm like, no, but the reason is not because I'm good at reading code. I mean, maybe a little bit, but it's because I made that same mistake before. And that's how I'm able to spot for it. And that's how I know to look for it, because I made the same mistake. So, you know, so I don't want to make it sound like, oh, it's easy because I'm super smart. No, it's easy because I put in hours and hours and days and months and years of work collectively, right? Yeah, and if it sounds that way, then, you know, just want to make sure they're on the same page, so it don't sound like, oh, I don't want to. Look, I feel like a lot of people have a ceiling for sure, given me, but I also feel like a lot of people don't, you know, get to it, right? Like if you look at how much time you're spending on, I don't know, video games, TV, and so, etc. Well, you know, and not to say that you shouldn't have a life balance, but in terms of like people saying, oh, I'm not smart, I'll never get it. Like, well, did you actually put in your full effort? Did you actually like hit the point where you cannot get any better? For most people, I don't think so, right? Like, I mean, and you may also argue that is it worthwhile to get better? And maybe the answer is no, and maybe the answer is like, oh, I don't need to get better at this. I already, you know, I already have a job or something like that, right? Or whatever your reason is. Like, I already have a job. Why do I need to get better at Leetcode, right? For example, which is fine, right? That's up to you. But you know, a lot of times, you know, I feel like people have not reached the point where like they're like, oh, I cannot be like, there's no world in which I'm smart enough for it. It's like, no, I mean, you know, maybe not, but a lot of people just have not put in the work yet, right? And, you know, and it's not about working hard for a day. It's not about working hard for a week. It's not about working hard for a month. It is a lot of years for me. So, I don't know. And that's it. Okay, let's actually get started. My apologies for this long intro. Hopefully it gives you something to think about and just, you know, allow you to better yourself. But let's take a look at today's problem. We have 2040, Cave's smallest product of 2 sorted arrays. Okay, you have 2 sorted array. Return the 1 base smallest product of num sub I, num sub j. Do they have to be unique? And this seems pretty standard-ish. There are a couple of ways to do it, maybe. But let's see. Actually, let me take a look at the constraints. Maybe not. Maybe I'm thinking of something else. Actually, I think I'm. No, I mean, I think you could do it. Maybe. I don't know. Maybe the constraints are a little bit odd. Sorry, I'm thinking about it a little bit. Oh, it's already sorted. That's fine. I mean, if it wasn't already sorted, I would have just sorted it. But yeah, K has to be goes to this. Okay, I mean, numbers are definitely very big, so we have to be careful. I think my first instinct was binary search, right? I mean, and even that is not. I mean, there are multiple ways of doing it, I think. But for me, maybe I could just count. Well, given a number T for target, how many products are there such that how many products are there such that it is less than that, right? And then from that you could get the K if you can't do that. And in theory, each query, meaning that for each T, it takes n log n time, right? Off my head. And how do I get n log n time? Well, for each number in one of the array, you binary search for the other one to get the upper bound, right? Or lower bound or whatever. Though of course this one is also very annoyingly just annoying, I think. Nothing more than that. It's just annoying because they're negative numbers, they're zeros, so it's not quite. Well, I guess the zero is pretty straightforward, but it's still like, and even negative values, like, you know, we've done multiplication things. We know how negative works. It's just more annoying. That's all, right? But as a result of that, it's gonna be n log m, which maybe is fast enough. But then you have to multiply that by log of t, which can be at least up to 10 to the 10, which is 32. So maybe that should be fast enough. But I guess we'll see. Honestly, I'm not quite. I don't know. We have to be careful, but I think that should be the right idea. Okay. So here maybe we can write a thing that is like get smaller product. I don't know if that's the right thing. But given a target, right, what do you want? So this gets the number of smaller products, or of products that are smaller than target, right? Or maybe smaller than equal to. I always, for this fund, for the K funds, I always forget. Do I want smaller than equal to, or I think smaller than equal to is fine. Wait, do I want? I always get this wrong, actually, or I'm not always, but I get it wrong at say half the time. So I have to think about it a little bit. So what I'm thinking about is whether it's smaller than or smaller than equal to. Technically, both is fine as long as you use it then now to convert the ith or kth number to it, right? So and the difference is the tie breaking, right? Because for example, with maybe I could write it out. For example, you want k is equal to 5, right? For example, and if k is equal to 5, you have I don't know, -1, and then you have, say, a lot of zeros. Just say zeros, right? And then now if it's smaller than this, for 0 it would give you f of 0 is equal to 2, right? And then f of 1 would equal to, I don't know, 8 or 9, right? So that means that the answer would then be, because this doesn't tell me the answer, right? Because then that means that the answer could either be, no, it tells me that the answer is 1, I suppose. Is that right? I guess so. No, but if it's more than equal to, then that means that 1 is a possible answer. Okay, no, I think this is right. It's more than equal to. I get this wrong a lot, which is, you know, something that I have to think about. Maybe I need to practice it more, but in any case, okay. So then now, yeah, we just keep track of the number of smaller. We have 4. I don't know. I guess we can. I don't know how I want to think about it. I mean, this is sorted anyway, so maybe that's fine. but we can also maybe pre-partition this, but okay, it's fine, it's fine. What I was thinking of is that this is sorted, right? But even if they're not sorted, we could partition nums1 into 3 chunks, negative, 0, and positive. But maybe that's a premature optimization. That's why I'm like, maybe that's fine. We don't need to make things more crazy. So then we could do, okay, if it's negative, then what happens? And we're looking for target, right? So that, what does that mean? That means that x times, so it is very easy to get wrong. So okay, so you have target, we want x times some number m that we're searching for, I don't know, as the target. So then now we want target divided by x, it's equal m, something like that. Oh wait, can you do that? Well, no, because x is negative, right? So if we divide by it, then it'll be on, we flip the signs, right? Yeah, I think that's right. The annoying thing is that now we have to do math on like, you know, there's a fraction, so we have to do some math on it. But basically, then now we do nums2 dot or bisect dot bisect left, or maybe bisect right, I don't know. We want to say, okay, so this number, right? So we want to count the number of numbers that are equal to or greater than or equal to this number, right? I think. No, so then it's this number. I think that's roughly right, though it's a little bit awkward, I think. So I think we want the ceiling of this, which this does, right? And just to be sure that, or to be clear, that's equal to target. We want something like this because we want to round up. Because if we round up, then now we could get the greater than equal to, but in a pure integer kind of way. And then the bisect left will contain it. So then that is just, let's just say n2 is equal to length of nums2. Then in this case, it'll be, I think n2 minus this, right? And the idea here is that nums2 is sorted, right? And here, we want to look for this number. We want to look for these numbers. So that means that it's going to be on the number that we found, the index that we found. We want the right side of it, the bigger part of it. And because we want the bigger part of it, that's how we, this is the index for the left side of it, the smaller side of it. So it's going to be n2 minus that because of the sign shift, right? Okay. And then else, if x is equal to 0, then we just choose target. If target is equal to 0, then smaller, I mean, then it's just the length of nums2, so n2. Else, if target is greater than 0, then all the numbers are smaller as well. So actually, I guess this could be greater than equal to, right? And then else, if the target is smaller than 0, then you have nothing, right? Because all of them are 0. So that's it. Else, x is greater than 0. And it's the same idea. So then now we have target x times some number m is less than or equal to target. We divide by x on both sides, but we don't flip the sign because, am I flipping the signs right? But no, we don't flip the signs because well, x is positive, right? So it's the same thing. Is it bisect left or bisect right? Because if it's equal to, then yeah, I think this is bisect right. Comes to target. I think this is. I think the way that okay. I mean, this is tricky to get right, and the way that I think about these to get the right indexes when I care, which I do sometimes, is to use a number, right? For example, if target is 10, x is 2, then this is going to be 5 exactly, right? Intentionally. That means that if we search for 5, do we want to include 5, right? So that means that, yeah, like I said, so if this is 5, we bisect right to include 5 on the left side, which I think is right. That was my intention. But let's say this is 11 divided by 2. This is then still 5. I guess fractional is okay. So I think we're fine then, maybe. If I'm wrong, then I guess we'll have to figure out how to debug. But I think that's roughly right. Right? And then we just return smarter for the thing. But then now we can, we can check whether smaller is number of target, right? So that's how you do the binary search. So good target. So that is you go to return get smaller product of target, whether that is greater than or equal to. Did I say that? Or I think it forget. Oh yeah, it should be greater than or equal to because of the thing that we said with F0 and F1, right? Okay. If not, then we have to check. But yeah, right is good. Right. This is. I can't English well, but now we're doing a binary search, and this lower bound is actually not 0, right? It's -0. Well, -0, sorry, negative infinity, which is bounded by. In the worst case, you have -10 to the 5th times 10 to the 5th, so that's going to be -10 to the 10th, right? Can I choose something more? I mean, I guess if you want to be specific, you could take the first and last and then multiply them or something like that. But I think it's fine. Let's just say -10 to the 10, and right is going to be 10 to the 10, right? And that's just because you have 10 to the 5th times 10 to the 5th, kind of. On let's say all the numbers, and that's how you get it. Anyway, the way that I write binary search is very much similar every time. The idea for me is just having inclusive bounds, and the reason why I like inclusive bounds is because then now you know that inside the answer is inside the bounds inclusively, right? You don't have to worry about it being none. And also that means that if the bound is one element, that is your answer. So that means that at the end of the loop is right is equal to left, so then you don't have to worry about left plus 1. Well, I don't know, the other thing. Yeah, and then middle is equal to and then if good of mid, that means that if this number is thing, that means that middle is valid, right? But we want to find a smaller number. So here right is equal to mid, else left is equal to mid plus 1 because it's too small. Right? Because if mid is less than k, then it's too small, we have to try bigger. And also mid cannot be the right answer. So that's why you do plus 1 instead of mid. You do mid plus 1 because it's no longer inside the bound. And since it's inclusive, you don't have to worry about anything. So that's basically how I would write it. Looks okay. Still possible off by 1, but I'm going to YOLO submit because I'm hot and tired. And hopefully I didn't make silly mistakes. Ooh, I did make a silly mistake. How did I get 56 instead of 54? Huh. Maybe I handle negative numbers, really? That is wild, actually. Huh. That's wild. Well, I mean, either that or I just handle one of these wrong. Alright, let's try printing. No easy days. No easy days. Even on these days. Okay, so 0. Oh god. 55 being 0 is weird, right? 55. So that's where this went wrong, right? Because 55 being 0 should have been a 1. Why is that? So for x and this is negative. Am I off by 1 here? Is this bisect left? Bisect right. Okay, so you have -6. It wants to search for, what's the target? 55. Oh, I see a source of issue. Because I'm not gonna lie, I'm really used to writing this as a way to write this, right? Because this is equal to this. But is it? Right? Usually this is true, for especially if they're both positive. I mean, if they're both positive, this is definitely true. But honestly, I don't know. Maybe, but what I mean is I don't know that I ever thought about this for negative numbers. So maybe that's why. Because basically now this is saying 55 plus x, but x is negative, so this makes it awkward. Because I don't think I ever thought about this as being negative before. So that's why it's wrong. Okay. I mean, today I learned something, so that's good. But how do I fix it? Well, in this case, we do know that x is negative because we explicitly do that. So it's okay. So it's 55 plus x. What is x? X is negative 6. So 55 minus 6, 49, minus 1 is 48, divided by a negative number, negative 6. 48 negative 6 is negative 8 probably. And negative 8, now you do bisect left, that is going to be 0. Yeah. Because, yeah. Well, actually, technically, it's going to be 1, sorry. But negative 9, so 9 is the array, so binary search for negative 8 is going to be, yeah. So, okay. So that's, I mean, today I learned that, yeah, this formula doesn't work for negative numbers. It's something that I don't know that I ever thought about, to be honest. Maybe I have, but... And then now we have to think about how to fix this, right? So and I know this is true for absolute values, so maybe I could just write something like this, right? And then now I know that I have to convert it back to negative. Do you though? Because maybe that's wrong too, because target can be negative. I mean, it's not negative in this case, but target can be negative. So this is, wow, this is a wonky one, honestly. Huh. How would I fix it? I mean, I guess maybe I could just do 0, something like this. But I'm also just, I mean, and that probably would fix it. Actually, let me check real quick. Actually, I don't know if that's true. Okay, I mean, let me just YOLO submit real quick. But I still want to learn I still want to learn how to figure that out for negative numbers, because I just never thought about it. Wow. And I don't know that I could derive something generic for it, but in general, I like using this because it's all integers, right? I don't have to worry about floating point, weirdness, rounding errors, and stuff like that. For this problem, for negative numbers for target and x, you have to, and maybe I'll think about it offline. And sorry, I would, in general, I actually don't mind exploring this, especially on stream, but I'm not gonna lie. It's very hot in here, and I gotta use the bathroom. Let's just say I had a really huge Chipotle for dinner, so I'll leave it up to you to know what that means. But yeah, I mean, if you're curious about my follow-up, I'll talk about it on my Discord, because, you know, maybe this is a spam for my Discord, but honestly, whatever. But yeah, I'll try to figure it out. But hopefully the logic still makes sense. We walk through it, and if the logic doesn't make sense, then what I urge is just visualization. Just walk through small examples. That's how I did it. I mean, I did try it in front of you. I know that maybe I may have some gaps in explaining it, only because I have the understanding of how bisect left works. So maybe I didn't go into bisect left detail that much, especially the difference between bisect left and bisect right. Some of these are implementation detail, but I do want you to kind of, you know, look, this is a channel. This is, you know, hopefully I'm guiding you the right way, but you still got to do homework. This is not a passive learning. You don't get good at this by understanding. You get good at this by doing. So there are some gaps, but I want you to do it. I want you to visualize it. I want you to draw out the numbers and why this bisect left and bisect right and how these things work. You have the idea, hopefully, from watching me. So you have the ideas. You have to kind of, you know, but getting gritty in the details, that's going to be on you. You have to do it to get better. You don't watch videos about running and wondering why you don't run. You're like, oh, I understand all there is to know about running. Why am I not running faster? No, you have to actually go run. So, all right, that's all I have for this one. Well, Actually, let's go over this real quick. This is O of n, and let's just say n1, right? It's O of n1 times log n2 for the binary search, right? So this is, oops, O of n1 log n2, and then this thing is going to be, say, I want to say O of r for range, right? And that's going to be, with 10 to the 10, what's 10 to the 10? And times 2, right? Because you go to negative. So it's like, I don't know, say 32 loops but you can also say O of r times, because each one of these has called one good function, which is this thing. So it's going to be O of r times n1 log n2, and there you go. That's all I have for this one. Let's look at the top of the code. Let's look at the bottom of the code, and that's all I have. Thanks for watching. Yeah, let me know in the comments what you think. Come to the Discord. I'll try to figure this out on the John, if you will, on the bathroom, but not on stream because that's just disgusting. So yeah, thanks for watching. Stay good, stay healthy, to good mental health. I'll see y'all later and take care. Bye bye.